Hola, hi, this is Al, your statistics instructor. Let's get to work. In this video, I would like to talk about a theorem that will be very useful to find probabilities. It's going to be useful to find the probability of the complement of any event A. Okay? So, this is the result that we're going to be showing here. We're going to give a mathematical proof of this result. Okay, here we go. So if A is any event, okay, any event, then the probability of its complement is given by the following: 1 minus the probability of A. So first, we're going to make an important observation here. Note that S, and remember that we use S to refer to the sample space, and S, the sample space, we could express the sample space like this: A union A complement. Is that clear? Okay. So next, notice that A intersection A complement equals the empty set, which means that A and A complement are mutually exclusive, right? Okay, so we're going to say that A and A complement are mutually exclusive. Mutually exclusive. But that means that if we want to compute the probability of S, that's the same as finding the probability of A union A complement. But since they're mutually exclusive, that happens to be probability of A plus probability of A complement. And again, we get to do this because A and A complement are mutually exclusive. Remember? Okay. Next, something else. What's the probability of the sample space? The probability of the sample space is 1, right? And we have that, we know that from the properties that a legit probability function must satisfy, right? It's one of the axioms. Our mathematician friends would tell us that, hey, that's an axiom of a probability function. So let me just say that probability of the sample space equals 1 by axiom 2. If we check our textbook, it's in that case they refer to this as the second property that a probability function must satisfy. So that's the second axiom. Okay? Okay. So, now, what we want is we want to find an expression for the probability of A complement. So next step, just solve for probability of A complement and we're done, right? So if we did that, if we do that, if we solve for the probability of A complement, we would have this, right? So we have shown that the probability of A complement equals 1 minus the probability of A for any event A. Okay? Well, that's it. Thank you for watching. Please take care and keep working hard. See you next time. Bye.